So the problem we left off with yesterday was the limit as x approaches 4 for the square root of x plus 5 minus 3, all divided by x minus 4. So here's the thing. When do we use this process? You're going to use it if there's a square root involved, some sort of root. This is the method that you're most likely going to use. If the first method doesn't work, what is always the first method? Plug it in. Plug it in. If we get an answer, pretty much, if we get any answer besides 0 over 0, we're good, right? Let's say we plug it in and we get something over 0. What's the answer going to be? Does not exist. Good. So pretty much if we get 0 over 0 when we do direct substitution, plug it in, that's when we have to do factoring, multiply by the conjugate, and the one we haven't talked about, which is common denominators. We're gonna give you a problem like that. So pretty much what we're gonna do today is we're gonna finish. We got one problem left. I think F is the problem we haven't finished, and then I'm gonna give you a couple other problems to do on your own to try, and then we'll be done. Tomorrow I'll give you assignment 2. Okay, practice assignment 2, and that's all we'll do in class is just work on that. Gives you some time to work on it. Gives you some time to ask questions and all that good stuff. Okay? All right. Okay, so let's look at F now. So F is what we call a complex fraction. It's got a fraction on top. It's got two fractions on top. 1 over x plus 4 minus 1/4. And then it's part of a bigger fraction, right? So it's called a complex fraction. When you have a fraction in a fraction, so it's called the complex fraction. Well, it doesn't really matter. First thing we got to do is plug in 0. Limit as x approaches 0. So when we plug in 0, let's see what we get. 1 over 0 plus 4 minus 1/4 over 0. 1/4 minus 1/4 over 0, and we get 0 over 0. We still have something left to do. So what are we going to do for this problem? Well, this problem doesn't have any roots, right? So I can't really, I can't do what I did before. But if you look on top, I got two fractions that are being subtracted. What I'm going to do is I'm going to actually subtract those two fractions, right? Instead of two separate fractions being subtracted, I'm going to subtract them. Well, let's see. Go back to elementary school in your head. What do you need before you can add or subtract fractions? Common denominators. That's where this method comes from, common denominators. So I'm going to focus on the top right now. I'll come back to the bottom, but for right now, I want to focus on the top. So I have 1 over x plus 4 minus 1/4. Right? So if you want to subtract, right now they're close, but they're not the same. One of them is a binomial, so I'm going to put parentheses around it, and one of them is a monomial, just 4. Common denominator, the easiest way to play the common denominator game is just to figure out what is missing. This guy over here, the parentheses guy, what is he missing? He's got it's an x plus 4, right? He's got an x plus 4. That's what he has. To be common, you have to be the same. So what is he missing that this guy has? X. He has an x, right? But what is he missing? He has an x already. What does this guy have? What does this guy have?
Negative?
No, not a negative. Just a 4, right? So some of you are like, well, he's already got a 4, right? No, he doesn't. This guy over here, yeah, he has something plus 4. So it's not 4. This over here is just a 4. This is something plus 4. So even though they share 4 in common, they don't have the same thing. They're not the same thing. So what the guy on the left is going to need is a 4 times in front. He needs this guy over here. So whatever you do to the bottom of a fraction, you have to do to the top. So since I multiplied the bottom by 4, I'm going to have to multiply the top by 4. So now let's go to the other guy. He's got just a 4. What is he missing? An x plus 4. So we got to include that here. So now what is our common denominator? They're both the same now, right? 4x plus 4. That's the common denominator. They both have the same thing. 4 times the quantity x plus 4. So now let's look at the top. The first one has a 4 times 1, right? So 4 times 1 is 4. And then it has a minus. Over here, it has 1 times both of these guys, right? It's actually not just a 1. It's actually a negative 1 because the negative goes with, it's minus, right? So what I'm going to do is I'm going to distribute negative 1. So when I distribute negative 1, I get negative 1x minus 4. So negative x, yeah.
So wouldn't that just be a plus x?
No, it's going to keep the negative in front. It stays a negative because it was negative 1 times x, so it's going to stay negative. So it's going to be negative x, or negative 1x, over 4x plus 4. So let's go back. Oh, and then, so let's put that part back. Let's put that part back, because that was only the top, right? That was only the top. So we're done with this guy. I'm going to put him back on top like that. So let's see what we got. So we're going to rewrite the whole problem. The limit as x approaches 0. So now instead of the 2 fractions, I have the 1 fraction that I'm going to put back. So negative x over 4x plus 4. And then I had the x on the bottom that I had at the beginning, right? So now, see if you can do this part in your head. If I plug in 0 for x, will I get something other than 0 over 0? Try to do some mental math. No, right? On top, I'm going to get 0 over 16. 0 over 16 is 0. Anything over 0 on top is always 0. And then I have 0 on bottom. So still 0 over 0. Still some work left to be done. Okay. So what am I going to do next? Well, the next thing I'm going to do is I have division here. So I'm going to rewrite this problem a little bit. I'm going to rewrite this problem. Still the limit as x approaches 0. So the top, instead of the fraction for division, I'm going to actually write the division symbol, and I'll tell you why in a second. Division x. Next, I subtracted the fractions. Now I'm going to try to divide the fractions. So how do we divide fractions? What's the rule for dividing anytime you want to divide by a fraction or divide fractions? There's a couple ways to say it. So there's 2 ways. Either multiply, change it to multiplication, and multiply by the reciprocal. Or the way I remember is keep, change, flip. Keep, change, flip. Keep the first guy. First fraction stays. Change to multiplication, and then flip this, reciprocal. So it's going to be 1 over x, yeah. So it's going to be the limit as x approaches 0. Keep, change, flip. Yep, there you go. What's going to happen when I turn it into a multiplication problem? Well, let's see. So when you multiply, you're going to get the limit as x approaches 0. So on top, I get negative x times 1, right? Multiply fractions straight across, right? Straight across, multiply fractions straight across. So I get negative x times 1 on top. On bottom, I'm going to get 4 times x and then times the binomial, right? What is this going to set up now? What can I do next? Before that, before I plug it in, I'm going to do that next. But before I do that, I want to make sure that I simplify it, right? Is there anything I can simplify? So yeah, I'm not going to do distributive property, but what can I do instead? Are there any monomials? I know I only have one binomial, but are there any monomials I can cancel out? The x, right? They're both monomials, so I can cross both of these guys out, divide them so they make 1. So now I have the limit as x approaches 0, negative 1 on top, 4 parentheses x plus 4 on the bottom. Now plug it in. So can't plug it into the top, so it's going to stay negative 1. I can plug it into the bottom, so it's going to be 0 plus 4 times 4, so it'll be negative 1/16. Done. Okay. All right. I want to give you another example like that. I want to give you one. So try to find some space. If you can't find any space, just do it on a piece of scratch paper or in your notebook somewhere. I want to give you another practice problem. Let's see. Okay. So the last one was F. We'll call this G. Okay, so the first one I'm going to give you is like the one we just did. Okay. I'm going to give you a couple more. I'm going to give you 3 problems total, and I want you to try them on your own. Oops. So I'll put the answers for each so you can check them as you. We'll do these together, but I want to give you a chance to try these on your own. Okay, so so I combine the top. There's only one fraction on the top now. It's not 2 fractions being subtracted. But I plugged in 0 for x, and I still got 0 over 0. Okay. So last step is I'm going to divide by the denominator, or divide by the reciprocal. So the limit as x approaches 0, so the top fraction divided by the bottom. Okay, so we're going to keep the first one. change to multiplication, flip reciprocal second one. So now we're gonna multiply straight across. I get the limit as x approaches 0. And it's negative x over 3 times x plus 3. The x's are going to cancel out because they're both monomials and they're both in the front. So I have the limit as x approaches 0, negative 1 over 3 times x plus 3. So then when I plug in 0, I can only plug it into the bottom. So it's going to be 3 times 3, and you'll get negative 1. Okay. So the notes I always post. So these are actually already posted. So if you're like, oh, I didn't catch that, that's why I post them. So I'll show you real quick where the notes are. So it's always with the weekly agenda. So this one, we're in week 2. So you see that PDF down here. So this is the live document that I'm actually writing on right now. I always upload it. Everything we're doing right now is up there. Okay. And then the lessons, the actual lessons I'm recording, are if you go to classwork and if you look up the class info materials, the YouTube playlist is at the top, and then you just click on that and just go by date or by title, and that's where they all are. So, okay. So just in case if you get behind, that's resources for you. Okay, there's G. Now let's try H. All right, so H. So you notice H doesn't have any, it's a fraction. It is a fraction. It's a rational expression. But top is a trinomial, bottom is a binomial. Okay, so first thing I'm going to do is I'm going to plug in 4. When you guys plugged in 4, you guys saw that you got 0 over 0. That means there's work left to be done. So what I'm going to do is I'm going to factor. I'm going to use the factoring technique. So I'm going to factor the top as a trinomial, and I'm going to factor the bottom as a binomial. So the green first. So the top is a trinomial. So when you factor a trinomial, first thing, is there a GCF? No. There actually, for the green, there is no GCF besides 1. So set up A, B, and C. A is the first coefficient in front of x squared. B is the second coefficient in front of x. C is the constant by itself. Okay. So A times C goes on top, B goes on the bottom. Okay. So the two numbers that multiply to be 4 and add to be negative 5, negative 4, negative 1. Yep. Okay. Now that I got those, I'm going to use the factoring box. So first term, the very, very first term is always going to go in the first section. And then the last term is always going to go in the last section. Okay? So x squared and positive 4. And then the two guys I came up with are going to go in the missing spots. So negative 4 with an x, negative 1 with an x. I always start with the first box, x squared, because it's easy to make x squared. It's just x times x. And then x times negative 4 will make negative 4x, and x times negative 1 makes negative 1x. So this guy can be rewritten as x minus 4 times x minus 1. That's the factored version. Okay, that's the green. The yellow is a binomial. So binomial, does it have a GCF besides 1? No. So I can't do that. Is it difference of squares? This one actually is difference of squares because it's 1x squared minus 16. So difference of squares is going to be x minus the square root and x plus the square root of 16. Okay. What's that? So yeah, x minus 4 is going to cancel out. Yes, yes it is. So when those cancel out, now I have the limit as x approaches 4, and I have x minus 1 and x plus 4. And then now you're going to do your substitution. And when you plug it in, you're going to get 3 over 8. That's the factoring method. Okay. And then the last one was the one with the root, right? The one with the root. So if it has a root and you're going to do a limit, like I said, more than likely, you're going to have to use a conjugate. It's a conjugate situation. Okay. So let me write that. Copy. Paste. Okay. So when you plug in 0 to the top, you're going to get square root of 1 minus 1. The square root of 1 is 1, minus 1 is 0, over 0, so you're going to get 0 over 0. The bottom is a monomial, but the top has a square root. Like I said, anytime there's roots, third roots, square roots, any type of root, more than likely this is the method you're going to use. Okay, it's the conjugate method. Okay, so for the conjugate method, I'm going to rewrite it. Square root x plus 1 minus 1. And you're going to multiply by the conjugate of the root. So the root is actually one part of the binomial. And then the other part is 1. And they both have a minus in, they will have a minus in front. So you're going to multiply by the conjugate of that guy. So that's, oops, not times, it's plus 1. Same thing. Okay. Anytime you're multiplying binomials times each other, and they're conjugates of each other. Anytime you're multiplying conjugate binomials, it's difference of squares. So the quick way of doing it is setting up difference of squares. So this first one minus the second one. So the first one is x plus 1, square root x plus 1. The second one is just 1. The bottom is just going to stay the way it was. Since those guys aren't conjugates, I'm going to leave it the way it was. Anytime you square a square root, the square root just goes away. That's the nice thing about doing square roots. So when I do that, it's going to be x plus 1, and then the square, and then 1 squared is just 1. And the bottom stays the same. Oops. Close the parentheses. So 1 minus 1 is just 0. So the ones on top are just going to cancel out. So I'll have the limit as x approaches 0 for x. And then the x's are both monomials, right? Inside the parentheses, binomial. So I can't touch that. But the x's are monomials. So now you can simplify those, and those will both become 1s. So you get 1 over x plus 1 square root. And then when you plug in 0 there, what do you get? 1/2? And you got it. Okay. So most of the time we evaluate what's called, anytime you evaluate means you're finding an answer. Like if I say evaluate, it means give me the answer. So anytime you evaluate limits, solve limits, if it's a graph, you're going to do what we did last week. You won't see a table very often. If you see a table, it's really easy. You just read the table, right? You read the table to see where it's going, right? I gave you an example of that on these notes. If it's an equation, always plug it in first. If it's not a plug-in situation, if you plug it in, you get 0 over 0. Do factoring, do conjugates, common denominators, any way you can manipulate it so that it will work. Okay? All right, so let's see what time we got. We finished a little early today. It's okay. So those are your notes. So tomorrow, I'm going to give you the assignment. I haven't made copies yet, so I'll give it to you tomorrow. I'm going to give you the assignment, and that's all we're going to work on tomorrow. Okay, it's just some more practice so you have time to answer questions. Although, yeah, it's just a homework. It's just a homework assignment. Yeah. So that's what we'll do.